Okay. Good morning, everyone. Uh, if you recall, then in our last class, we started the LR0 parsing and SLR1 parsing. Mainly, we started with the bottom-up parsing technique. Under that, uh, we said that four categories are there: LR0, SLR1, LALR, and CLR. In my last class, we seen that what is called SR conflict and what is called RR conflict. Subsequently, we also moved to the portions what is called augmentation, what is called closure, and what is called go to function, and how a complete state transition diagram we can formulate for that. But we did not take any decision that for that grammar whether the grammar is LR0 or SLR1. So now today we will be looking at into that part, and also we will be moving into CLR and LALR part, and we will make a detailed analysis on it. So today's video will be a bit lengthy, but will be very important for you. Okay, let's switch to that particular segment now. Okay. Now first, let me write some portion over here so that you can remember some of the thing that I had told last time. That let if A is a production and it has this A is a non-terminal and it has a production let BC, and B has a production let this is D, for example, and C has a production like M. Now for that production, what is called augmentation? Augmentation means I will be adding A dash to A, and I will be performing dot operator over here. So first, no need to perform the dot operator. First, once I add this A dash to A, that is called augmentation, and subsequently all the productions I will be adding B to D and C to M. Correct? So this will be the augmented production, right? This is called augmentation. Correct. Once the augmentation is done, you have to perform the closure of A dash to A. So what is closure of A dash to A? You have to put a dot operator before the non-terminal, correct? A dash to dot A. And that A to be expanded. That A can be expanded in which format? Can be B dot BC. And how this B can be expanded? B can be expanded to B dot D. Sorry, here not B dot D, dot BD. It will be dot D, correct? But here you check that D cannot be expanded because it is a terminal, and even C cannot be expanded because here the dot operator is appearing before B. So only we can expand the B. So that means this closure set will contain only these three production, not four production. Though the main grammar G was having these three production, after augmentation four production, but after finding the closure three productions we have find it out. But now when we will be performing the go to function, definitely we need to perform over this set, not over this set. So if we are performing the go to function, when we will be moving over A, so it will be A to A dot. This will be one state, dot will be moving. Another will be moving over capital B. So it will be A to B dot C. And now see that capital C is a non-terminal, correct? And before that a dot operator is there. So C to be expanded. So C can be expanded. So which extension should I take? So we need to check the parent set. I said now this is the parent set you should consider. Correct? So I termed it as a P naught, parent set. So C can be expanded to C2M. So I am writing C2 dot M. Right? No more expansion is possible. So I am marking it is another set. Right? So this is an add-on. Now another movement is possible over this D terminal. So it will be B2 D dot. Now no further movement, so let I am marking it is I0 state. It is I1 state and I2 state. Let I am marking it as a I state, initial state. Now I not and I1, I cannot move further from these two states, correct? Only I can move from the state I1. What are the movements are possible? So first movement is possible over capital C. So it will be A to B C dot, right? No other possibilities are there. And another movement is possible over M. So it will be C to M dot, right? So this is the possibility. Now, this is a complete diagram we have seen for a grammar. First, a grammar was given, augmentation, closure, and then go to function. And we have seen a state transition diagram. This part we had seen in our last class, correct? Also, we came to know two prominent factors. One is called SR conflict and one was called RR conflict. Right? SR conflict was meaning was if there is a production let X is generating M n dot, correct? Another production is there, Y is generating let B dot C. Let they are under a single state. Let this is called I10 state. So here for production X, this is being reduced because no other movement is possible over dot. But here the movement is possible over dot because dot can come over here. So this is called shifting. Here it is reduced. So this is the conflict generated in the state transition diagram, which is termed as SR conflict. And if I had this conflict M n dot and Y2 BC dot, correct, and they are in a same state, let the state number is 11. Then what we will be finding, M n dot and BC dot both are reduced because no dot movement is possible here, no dot movement is possible. So it is comes under the RR conflict. This is comes under the SR conflict, correct? Now we will be taking a decision over here. If you can recall that I said in my last video that the L at 0 was the smallest set. This was the L at 0. Above the L at 0, it was SLR1. Correct? Above there, it was LALR. Above there, it was CLR. CLR1. And your LL1 grammar was up to here. This was the diagram. Correct? Now, today our focus, initially not today, now our focus is whether the grammar, that G that we have taken here, that is LR0 or SLR1. First, we will be looking at into these two aspects, LR0 aspect and SLR1 aspect. Later, we will be moving to LALR and CLR. Okay. So the first thing you have to remember. What thing you have to remember? The first point, you should note down the point. If any state contains any conflict, if any states contains any conflict in terms of SR conflict or RR conflict, the grammar cannot be L at 0. So L at 0 cannot, when it cannot be not L at 0, if SR or RR conflict. Not L at 0 if SR and RR conflict. Correct. Then if not L at 0, then can I say SLR1? No, I cannot say SLR1. To test SLR1, some more parameter to be considered. What more parameter? Okay. First, let us see the grammar that we have taken today, whether the grammar is L at 0 or not. So initially the grammar was G, right? In how many states we have generated? I is not, I1, I2, let this is I3 and this is I4. Here none of the states I have find it out where either SR conflict or RR conflict is present. Any states are there? Here is a single production now for I0 because one is reduced. Another is shift was there, or if reduced was there, then I could have taken a decision that it was not L at 0. As there is a single production, so it is fine. For I2, it is also fine. For I3, it is also fine. For I4, it is also fine. For I1, it is shifting. And for here also, it is shifting. So shift, no problem. So this state also, it is fine. So that means I can tell that the grammar is LR0. And if the grammar is LR0, then definitely I can tell the grammar is by default SLR1, LALR, and CLR. But certainly I cannot tell whether the grammar is LL1 or not, right? No? Because it may belongs to that region. That is different. Now, one thing is sure with that, if the grammar is LR0, then definitely SLR1, LALR, and CLR it will satisfy. So first thing, the grammar that today we have taken, the grammar is LR0. Now, I'm coming to the point that if the grammar, after performing the state transition diagram, if the grammar contains any conflict, SR conflict or RR conflict, then what will happen? Okay. So I am erasing this diagram. I have to write some more portion over here. Now, if there is a SR conflict, for SR conflict case, you have to check. This is arrow means I want to indicate, correct? Na? This arrow does not mean it is a straight transition diagram. You have to find it out. The follow here, the X production is reduced, correct? Na? No further movement from X is possible. First production. Second production is possible. Possibility is there to shift over C, capital C. So here you have to find it out. The follow of X, follow of this non-terminal X. You know the calculation of follow. But here the follow calculation will be simple because one or two production will be given for you to perform. You have to perform the intersection with the variable over which it is switching. It is C. So you need to find it out, the first of C. Means over which it is switching. It is a terminal, then I can write directly over here. If it is a non-terminal, then I should write the first. So follow of X and first of this variable, this part. First of this part and follow of this part. Intersection, if it is phi, then SLR1. We'll be taking examples to make it clear. Don't worry about that. For reduce part, please remember when I am taking follow, if something is reduced, here for X production it is reduced, that's why we took follow. If it is not reduced, then we will take the first. Here Y was not reduced, that's why I take the first of C. For the RR conflict, X and Y both are reduced. So we will take the follow of X intersection, the follow of Y. And the same ideology we will check. If equal to phi, then SLR1. Right. So try to remember, if the production is reduced, then I will take the follow of that part, and the part that is shifting I will take the first, and I will check the intersection of these two segments, follow of non-terminal and first of this terminal over which it is shifting, and we will be performing the intersection. If it is phi, then SLR1. For reduce case, we will be performing the follow, and also here also we will be performing the follow, and if it is phi, then it is SLR1. Okay. Now move to one example so that it will make it clear before you. Okay. So last time, I hope you can remember that we took this example. Let me check. Yes, we took this example last day, that this was the this was the initial grammar that was given to you. Let me rotate this screen. So this was the original grammar given to you. After that, you perform the augmentation part. This was called augmented grammar because this production was added. After that, you perform the closure of E dash to E, the first production. So this was the closure set. After that, you have to execute the goto function. Under the goto function, this was the state transition diagram. Correct? I hope you have made a practice on it and you could have generated this set. Now, if you can understand this example, all the cases you can understand. Just you have to remember a few things, that if any conflicts are there, then the grammar cannot be LRC. If conflicts are there, I have to perform these two operations. For reduce case, intersection of follows. For shift reduce case, intersection of follow and first. Okay. Now see, in this diagram also, in a class note also, if you look, then you can see that I have given that the grammar is not LR0, as problems are located in I2 and I9 state. I2 and I9 state, and also I1 state. Three states are there, I2, I9 and I1, where the problems are located. That means these three states having SR or RR conflict. So let us check I2 state. Yes, there is I2 state, this one. Let me mark in red. Here an I2 state, in this part you check that here this is reduced and here this is shifting. So here the conflict is SR conflict. I2, then I9, this is I8, where is I9, this is I9. Here also this is reduced, T dot, and here it is shifting. So here it is a SR conflict. I1, this is I1 state. Here this is reduced and here also it is shifting. So here also SR conflict. So three cases we have find it out where the SR conflicts are there. If one conflict is there, then definitely the grammar cannot be LR0. So that decision we have taken, that is why. So the grammar is not LR0. Fine. Now, whether the grammar is SLR1 or not. So the first set it was LR0. We check it is not SLR0. Sorry, LR0. We need to check the upper set, SLR1 or not. Okay. So we'll be moving to that part. Now, what you know, that if SR conflicts are there, what we had to perform? We have to perform for this case, if I consider for this case, so we have to perform the follow of E dash, right? Just I'm writing intersection. First of what operator after dot, what is the operator? Plus. First of plus. And if I find out it is 5, then I have to take a decision. But no, I cannot take a decision because I have to check for this state and this state also to take a final call. Okay. Now see, I have shown for I2 and I9 state here and I1 state also. So what is the follow of P? I have calculated the follow of P here. It is dollar plus and bracket. Follow of P. Okay. Here it should be this is I1, I2. Now this is follow of E. Follow of E. Here you check that in here we have to perform the follow of E dash intersection first of plus operator. For this I2 we have to perform, here I am writing the follow of E, correct, right, because this is reduced, and for this one this is shifting intersection the first of start operator. For I9 we have to perform the follow up. This is E is reduced, so follow up E intersection. Here the start it is moving, so first of start, right? So this is the three cases we have find it out. And I2 case for I2 state and for I9 state, the our findings are similar because we are finding follow OP and fast of star. It was follow OP and fast of star. Correct. That is the reason I have made it in a single format over here. I2 and I9, one case I have taken, and for I1 another case I have taken. Okay. Now what is the follow OP? We have to check follow OP. Now let us check what is the follow OP. So okay. So here if I take that, if I take the here, you know that follow up E dash will be in follow up E. Correct. So okay, first I'm writing the follow. Let me check. Let me take a page so that it will be clear before you. We have to find out the follow up, right? This is our objective. Now, as per the production, I am writing E dash 2 dot E, E2 dot E plus T, E2 dot T, then T2 dot T star F, and then T2 dot F, F2 dot E bracket, and F2 ID. Correct. So these are the productions that I had. Correct. Now we have to find out the follow-up, right? Now let's see that here, you know that I said na, I can make it in this format, follow up E epsilon. So rule number 3, if you can remember, the follow up E dash will be in follow up E. So I am writing follow up E, it will take whatever I will get from follow up E dash. Rule number 2, I am writing here rule number 3, R3, right? And for here, okay, for here what we can take, you can, if you don't want to consider this dot operator, then also you may don't consider it. Okay, no problem will be there, because here our intention is to calculate the follow, not moving of dot operator. So better you forget the dot operator over here and only consider this segment. So E dash to epsilon, what you have taken epsilon E. So follow up E dash, it is coming to follow up E. Now the next production is E to E plus T. You know that I can apply the rule number 2 over here, alpha to beta gamma. So if I consider here also epsilon is here, so that means I can make it as a first segment, I can make it as a second segment, I can make it as a third segment. So that means follow up E, it will contain the first of plus capital T, right? This part I will get. Okay. From here I have taken something, from here I have taken something, from here I will not get anything. From here no E terms are there. From here no E terms are here. For here also no E terms, and here there is E terms is here, E is there, right? So here this is a segment 1, this is a segment 2, and this is a segment 3. So from here what I can write, the follow up E will take the first of this bracket symbol. This is the bracket third segment. Here I have applied rule number 2, the follow function rule number 2. Okay. Now this is the find it out findings that we have obtained here, right? Okay. Now let me check the color, change the color. Okay. Now you know that follow up E dash, we have to calculate the follow up E dash. You know what is a follow up E dash? We know follow up E dash will contain dollar. This is very simple because it is the root production, right? And nowhere E dash is there. So only single time the follow up E dash is fine. Now follow up E, what it will contain? From the first finding, here the first finding, first means the initial, our initial finding is follow up E dash, that is dollar, it will contain dollar. Then from the second finding, first of plus T, that means the plus operator. Our third finding, it is bracket. First of bracket means bracket. So it is these three operators we have find it out: dollar, plus, and bracket, right? And that thing, those parameters I have written out here: dollar, plus, and bracket. Correct. So follow up we calculated. Intersection, first of start. You know now I have sent. I already said the first of start because the dot operator is appearing here. So first of start. Now, if I perform the intersection, so definitely it is fine because dollar, plus, and bracket, and here this is this first is only containing the start. Intersection of these two set, it is fine. So that means for I2 and I9 there is no problem. For state I1, okay, for I1 state, you check just before, we have to perform the follow up EDAS and first of plus operator. So follow up EDAS, just we have calculated, it is dollar. It is dollar, you know, follow up EDAS, it is dollar. And first of this function, that means first of plus operator. So here I am writing intersection. It is plus operator. So again, it is fine. So here also no problem, right? So we find it out that three states were there in the state transition diagram where the problems were located. So we decided the grammar was not LR0. Now we goes for checking for SLR1. Under SLR1, with the three conflicts that we had, we applied the rules and we find it out for all the cases. For all the cases, we have find it out fine. So that means we can tell the grammar is SLR1, no problem with that. I hope the idea is clear. And once the grammar is SLR1, so that means the grammar is not LR0. So grammar is SLR1. That means the grammar belongs to this region. This is SLR1. That means it will by default will be LALR and by default it will be CLR. But the grammar, that means it is LALR, it is CLR, and it was LR0. So that means the grammar lies in this region. Right. So what we have seen, the same thing we have to do, state transition diagram. We have to check the conflicts. If conflicts are there, not LR0. For conflicts, we need to check whether the intersection is phi or not. If we find it out that there is a SIP reduce case, then we have to find it out the follow and first. Follow means what is being reduced. For that, here this X is reduced. For that, we have to find it out follow. Whatever is shifting, for that we have to take the first after the dot, not for the initial production. For reduce, you know, for reduce case, we will take a follow. So follow of both the sets we will take. So follow intersection by follow. Okay, and it should be phi. For all the conflicts, it should be phi. Then only SLR1. Numerous example we will be looking from here, and I hope once we go through it, it will be clear before you. Okay. Now let's move to one more example that will be good for you to understand. Okay. Now, if I take this is a gate questions also, it also came in your exam also, in your MACOUT exam, that this is a grammar is given, correct? This grammar contains two production. Here I'm writing S to S, or S is generating small a. This is a small grammar is given to you, and they have asked you to check whether the grammar is LR0 or SLR1. LALR and CLR we are not checking. Later we will check. But certainly we know if the grammar is LR0, by default it will be SLR, by default it will be CLR, by default it will be LALR. Okay. Now let us move to our discussion. So first, you know what we had to do. We have to append. Let me change the color. We have to augment the grammar. So augmentation means S dash to S will be the augmentation part. Then we have to perform the closure of S dash to S. So what will be there? S dash, it will generate dot S. This S will generate this operator S, this operator or this production, and S will be having another production, that is S2A. So dot A. So this is the set we have built up here. S2 dot A. Correct? Now we have to move over states. So the same thing that I have written out here, let it is I0. So here the I0, same I0 I have written out here. Correct? And now you can see the propagation from here, because there is a propagation is possible over S, propagation is possible over bracket, and possibility for propagation over A is there. Once I made the propagation, how many states we find it out? I1, I2, I3, I4, I5, including I0, the total 6 states are there. So in any of the states, have we find it out any conflict? These states does not have any conflict because it has a single production. These states also it is fine. For this state it is also fine. For this state it is also fine. But for this state, here there is a shifting. Okay. Here also shifting. Here also shifting. So if all are shifting, we don't have any problem. So this state also does not have any problem. That means the grammar is L at 0, we can decide. If L at 0, that means we can tell it is SLR1. We also can tell that the grammar is LR1, and simultaneously we can tell the grammar is CLR1. But again, I am telling regarding LALR and CLR, we had to take a separate call. We will look into that how LALR and CLR dedicatedly can be checked. Later we will be moving on to that. Okay. Okay. Now, if I consider this grammar, if I ask you to check whether the grammar is LR0 or not, or SLR1, this is the grammar. Example number 30 is given to you. This is the grammar. Capital C, this is a small c, capital C, or small d, small c, capital D are terminal. This is non-terminal. S is the root production. So first stage is augmentation. We had added S dash to S, right? Once this augmentation is done, then the closure functions we have to perform. So here this is a closure function, but you might be wondering why I have written some more part over here, because here some symbols are there like dollar, like that. So for this LALR, this was the example for LALR, you may not consider it, correct? So just you may discard it. Just okay. So S dash 2 dot S, S2 dot CC, this capital C can be broken into this format or can be broken into this format. After that, we have to perform the goto function, correct? We will be moving to goto function. Now in the goto function, just discard this segment. I am erasing this part. Later we will be coming to this example for LALR, and we will be checking the associated parts. Okay, everything I have removed. So if I make the transition, now it will move over S. So the first transition over S, it is I1 state, no problem. It will move over capital C. So it has a movement over capital C. For I2 state, you check. And I2 state also does not have any problem. Here the shifting, here also shifting, here also shifting. For small c, here also you can check that here also it is moving. Capital C means for this production we were doing basically. So dot will be coming here, you know. So C dot C, and this C to be expanded from the parent production. This is a parent's production. I said you can check. Actually, this is not a parent production. You should take this one as a parent production, rather this one. This is parent P naught. Correct. For all the productions are there, you should take it as a parent production. After augmentation, you should consider this as a parent production. Okay. Now, for C, okay, just we were checking that for small c, the movement was there. For capital C, it was breaking into two segments. Dot D also. Here also shifting, here also shifting, here also shifting. So no problems are located. For D, here there is a simple movement is there for I4 state. No problems are there. Again, we make a transition from I2 over here. Over capital C, no problem. Over small c, there is a no problem. There is a dot shift. This is a shift. This is a shift. For when we are moving over D, I7, there is a single production. No problem. Correct. Now from here we are moving over capital C. Here we landed to I9 state. Single production. No problem. Here from I3 states, when we are moving over capital C, here this is I8 state. Here also single production. So all the states does not contain any sort of SR conflict or RR conflict. No conflicts are there, right? That means now you can take a decision. The grammar is LR0 by diff, and also the grammar is SLR, LALR, and CLR. All the decisions you can take over here. The grammar is there, right? So two back-to-back examples we have seen over here. I hope now you can understand that if a grammar is given to you, now you are sufficient to check whether the grammar is LR0 or SLR1 or not. Okay. Now let's move to the our next discussion over whether the grammar is LALR or CLR or not. Correct. Now let's see that particular segment. Let me check whether any more examples can I discuss over here or not. Okay, numerous examples I have given here. So you may not consider this part, like here also. What suggestions I will be giving today, that let me start the CLR and LLR part tomorrow. Before starting CLR and LLR part, numerous examples I have given over here. Already I have solved it in my copy. You should check it. And also, for example, for this one, you check the given that example number 34. Here they are asking you to check whether the grammar is SLR or not. So like this was the initial grammar. You have to first perform the augmentation, though I did not make it because initially you perform the augmentation S dash to S, then in the first movement over S you will land to S dash to S dot, because this is the, I said now augmentation mean I am adding a compartment for safety purpose. For augmented grammar, never a conflicts it will generate, because it will be having one single production, it will move to the end state in the very first. Now, once I move over different segment, I find out a SR conflict over here, that the grammar is not LR0. That means we will be checking for whether the grammar is SLR1 or not. We will be checking for that. SR conflict means we have to find out the follow for this A and first for this C. Correct? Now here we calculated that follow for A, you check. I have termed this as set X. Follow for A, it is containing two part A and C, and first of this C means small c after the dot here the C. Once I calculate the whether it is phi or not, no, the intersection is not phi because C is common between them. So the grammar is not SLR1. So I have marked, right, and not also LR0. I am not commenting on LL1. Rather, because already you know how to check whether the grammar is LL1 or not. Our focus is main on is LR0 or SLR1. Okay. Some more examples are given over here. You should make a complete practice on it, LR0 and SLR1. In the next video, we will be moving to CLR and LLR part. If I quickly summarize what we have covered today, we started with SR and RR conflict. Then we take an example why we've seen that it is not always possible that the expansion is always will be from this state. Means here you check that these states were containing 4 states, but after the closure only 3 states it was coming, right? That's why every time when you will be expanding, you need to check your parent set P naught. If any conflicts were there, SR or RR in the grammar is not LR0. For SR conflict, you have to check follow first. For RR conflict, you have to perform the follow intersection. If it is fine, then the grammar is fine. And if the grammar is LR0, by default SLR1, by default LALR, and by default CLR. Okay. That's all up to today's class. Tomorrow we will be starting the next segment.